Now let's discuss a calculation of phasors. First of all, we will discuss the addition and subtraction between sinusoids with the same frequency. If we make the addition and subtraction between two sinusoids without phasors, we need to make complicated trigonometric transforms, and that's the difficulty of solving UR by KVL previously. And now we make some changes. The first sinusoid equals to this. The second sinusoid equals this. U1 point equals a phasor whose amplitude is U1 and the phase angle is psi1, the same as U2 point. Okay, let's calculate their addition now. We've known that we can do like this. And then we can get this. It means if we can use U1 point and U2 point to calculate their addition, we can use the mapping relationship to get the time domain expression of U. Next, we will discuss the integral and the differential of sinusoids. For this sinusoid, the corresponding complex function is like this. And now we will make the differential. As we know, the calculation order between taking out the imaginary part and making differential can be exchanged. And the square root of 2 times I is a constant. Thus, we can make a differential only on e to the power of j omega t. Maybe you've noticed that j omega times I point is a phasor with which di over dt corresponding to. That means that to make the derivation of a sinusoid is to timing the phasor of the sinusoid I point with j omega. Next, we will draw the phasor of I and di over dt in the complex plane. For convenience, we suppose that omega equals to 1. Suppose the phasor of the current is like this. Then the phasor of di over dt equals j times I. According to the discussion we made, j is a rotating factor, meaning that the phasor I rotating counterclockwise by 90 degrees. To expand the differential discussion, we can find that the integral of I is corresponding to the phasor of I over j omega, or rather, minus j times the phasor of I over omega. We also draw the phasor of the integral of I in the same complex plane, and suppose omega equaling 1. Then minus j is also a rotating factor, which means rotating clockwise by 90 degrees.